Good afternoon, everybody. My name is Paul Lewis. Welcome to day 2 of ENO's Transit Cost and Project Delivery Symposium. We're very excited to launch this day where we're focusing mostly on other research that has been going on the subject of public transit project delivery and its related components. So these first sessions there's several concurrent ones where we're featuring some of the most interesting things going on, and these are some of our collaborators. And particularly today, and on this session, we're going to be hearing from some folks from Northeastern University who I will introduce in just a moment. But I want to have a couple housekeeping comments for those on the live stream. First, if you are looking to access this or other sessions, you can do so on the agenda tab on the left-hand side of your screen in Socio. All of these sessions will be recorded and posted on the Socio site, so you can go back and access this or any other session that you may have missed. Particularly, this is important for concurrent panels like the session that's going on right now. During this session, at least on the live stream, you can enter questions that you have in the chat on the right-hand side of your screen. So please feel free to enter those at any time, and our presenters will get to those after their talk. And we're going to be on this panel for the next hour. So this will end promptly at 1 p.m. Eastern. So there will be a 30-minute break from 1 to 1:30 after this session. And then we will reconvene with another panel with some other researchers that we've been collaborating with to talk about how all of these different efforts fit together. So please tune into that one at 1:30. Again, you can find all of that information in the Socio platform on the agenda tab. And then finally, at the conclusion of the afternoon session, there will be some optional networking session rooms available via Zoom. You can access this through the link on the Socio site. It's been a really cool opportunity, as we experienced yesterday, to network and talk about some of the issues of the day. So without further ado, I want to introduce our speakers today. First, we will have Ali Touran, who's a professor of Civil and Environmental Engineering at Northeastern University. We also have with him Nan Gao, who is a PhD candidate at Northeastern University. And Nan will be on to help answer some questions and get into some of the specifics as Ali is going through his slides. We've got about 40 minutes of a presentation, which we'll be able to see Ali's screen and his slides here in just a moment. And the topic is entitled, let me make sure I get this right, Transit Projects, Risk Assessment, Cost Performance, and Risk Mining of Newspaper Articles. So we're going to be really talking about the risk side of things here, and learning about some of the leading edge work that's happening at Northeastern under Ali's direction. So without further ado, I'm gonna disappear for a little while. I'm going to be monitoring the questions. I will come back on at the conclusion of his presentation, and then we will we'll go get to all of the questions that you have following that. So thanks everybody, and Ali, please take it away.
Thank you, Paul. Good afternoon, everyone. Very happy to be here. It's an honor to be presenting to this group that are involved with transit engineering and research. And I've prepared this presentation based on some of the work that I've done in the past couple of decades and what's going on right now. So it's sort of three distinct portions to that. They are sort of interrelated. They all have to do with the uncertainty with the cost and schedule in transit projects. So the first portion, I'm just going to provide an overview of the risk assessment, the purpose of that, and what the Federal Transit Administration has done in this area. In the second part, I will be talking about the study that we did, which resulted in the publication of a paper that looked at the current trend of performance improvement in delivering the transit projects, and finally end up the presentation with going over the research that we're doing right now, which involves text mining and automatic extraction of relevant information from newspaper articles as related to transit project risks and uncertainties. So uh, the first part is an overview of risk assessment, probably um, is really a review of what we have seen in the United States with respect to risk assessment of transportation projects. In general, I want to start with a simple definition that the risk assessment and risk management offers a systematic approach to understanding uncertainties surrounding the projects. And we do the risk assessment to be able to identify the strategies to mitigate risk, to take advantage of opportunities, and also to establish the contingency budget so that we do not run out of time or money during the project. And a successful, carefully planned risk analysis will lead into the improved communication within project team, helps to educate the public about the issues that may affect the project, and also providing more realistic estimates of project cost and duration. That's very important because when this whole idea of doing risk assessment and coming up with risk and range estimating came about in early 2000s, one of the issues that the public agencies were facing was criticism from the public that they every day saw these things in the papers that such and such project went over, or the duration is way too late, and they was thinking that maybe it makes sense to bring a methodology to tell the public that the cost estimate, a single cost estimate, could have some inherent flaws, and the best that we can do is to provide a reasonable range with the possible contingencies that might befall the project, so that everybody is better prepared to understand the issues and difficulties. Uh, a little bit of history: the use of probabilistic methods in planning the transportation projects, although it's much older in oil and gas and so forth, but in transportation, it started in early 2000s. State of Washington DOT came with the manual for guidebook for conducting probabilistic risk assessments. Federal Transit Administration, since 2003, has required all the new start projects to have conduct a detailed probabilistic risk assessment. And then FHWA also published a guide to risk analysis in 2006. We at Northeastern has been working on this since 1990s, and in fact, the first report that was published by the sponsorship of the Federal Transit Administration, we were the author for that. It came out in 1994, and as you can see, the title says Risk Assessment in Fixed Guideway Construction. So that's specifically for construction, and that dates back to 1994. It took about 10 years for the FTA, I guess, to sort of not adopt that necessarily, but adopt the concepts that were described in that booklet, in that guide. So in 2005, TCRP funded the project, and the principal investigator was the firm of Booz Allen and Hamilton, and I happened to be a member of the team in which they looked at the issue of cost overruns in transit projects, what were some of the causes, at what point in the project development phase these cost increases or schedule delays occurred, and some of the issues that were identified and highlighted based on the research and interviews. I'm listing this here without necessarily spending too much time to get into that, but these were some of the main reasons, causes of cost overruns. It's like scope creep, or the mistakes in the estimates, or like the uncertainty on some specific costs that were notorious for being overrun, like real estate acquisition costs, or not considering inflation or escalation in the budget that was reported in the DEIS report, which later on basically led to some sort of a confusion, and newspapers kept reporting those items and expecting the project to be completed within that original cost estimate. The complexity of the project, the length of project development, these all contributed to the difference between the actual costs and the estimated cost. And in a nutshell, if you look at the project development phase, and I hope that these phases are still valid for transit projects: conceptual planning, alternative analysis, PE, and final design. Uh, in these different phases, the accuracy of cost estimate obviously varies. That's simply because information required to do an accurate cost estimate is not available in the early stages of the project. So in fact, the potential values of the cost are spread over a larger range. As more design is completed, the distribution for the potential cost becomes tighter. We never get an exact number until the project is finished and all the numbers have been added up, and that's the only time where we have like a point estimate for the cost. Otherwise, even when you go to the bid at the end of 100% design, still there is a range, a variance for the project costs. So what did the FTA's approach in risk assessment entail? Um, I could detect two specific efforts. The first one, which I call it method one, involved identifying the risk factors, developing the risk register, quantifying the effect of risk register on cost and schedule, and then using the simulation approach to come up with the distribution of cost. Many of you might have been involved in some of those earlier risk assessment studies. Is a relatively lengthy process, relatively costly process, but it was a process where it brought different people, different players to the same room, to the same table. They were able to communicate with each other. They talk about the issues that can affect the project. And in fact, I believe that's probably the most important contribution of the risk assessment exercise, to improve the communication and understanding between the project players rather than estimating a very accurate cost, because it turned out to be elusive even after all that effort. Still, you could come up with cases where the actual cost exceeded the worst pessimistic result of the risk assessment, unfortunately. So the key elements of the risk assessment, as I mentioned, we came up with a 6-step process to validate the base conditions, meaning go through your cost estimate, make sure everything is correct, remove all the contingencies, then go to a risk workshop, identify the risk, list them list them in a risk register. Let me see, I put an example. Here is an example of risk register where the, the risk is explained, the, the, the effect of the risk is explained, and then the impact of the risk on both cost and schedule is quantified with the help of the experts that have been involved with the development of the project or are later working as the project management oversight team. So your risk register will now list all these different risk factors, you combine them in some reasonably accurate mathematical way to see the combined effect of all these risks by considering the potential correlations between these different risk factors and calculating the total variance for the project. So the result of this risk workshop would come as a risk report. The risk report will be reviewed. They would convene a mitigation workshop. They try to come up with solutions for some of the major, cost drivers in the project, and they develop a risk mitigation plan that can work as a guidebook during the construction phase to make sure that the project will meet its milestones given the requirements of cost and schedule. So the outcome would look something like this. It's just a hypothetical project in which the total cost, instead of being a single number, now was a range. Now, depending on the level of comfort for the owner, like for example, want to be 80% sure that I have enough money, then you can select the 80% budget, and that 80% budget will include the necessary contingency that will give you protection 80% of the time. So that was the first approach that was used on several major risk assessment projects. And the general idea was when you go through the risk assessment workshop, the range of the possible values for your cost, for example, is this green curve here. And by mitigating the impact of these risk factors that have been identified, you hope to get to this, the blue one that has been dotted. You can see that it's another distribution. It means that still there's uncertainty even after mitigating it, except that you're hoping that the variance or the spread of the data is a little bit tighter. And also the expected value of the cost is smaller than the one prior to do the risk assessment. That's the best that you can expect from the risk assessment. There's no guarantee that you'll be able to have enough money or enough time to finish the project, but hopefully it's an improvement. So FTA was not, as far as I could understand, was not happy with some of the results of the risk assessments that were published. I mean, published internally, of course, for the project. Even the ranges that were the result of the risk assessment in a number of cases were completely exceeded, meaning that the actual cost came larger than the worst scenario. So they thought, okay, maybe the process of sitting at the table and trying to mine the risk and estimating the intensity of the risk has been a little bit overall optimistic. We already know that many of our projects goes over the budget by 40%, 50%. So let's start from those brackets and try to fill in the space between the brackets such that it will fit and suit the characteristics of the project. So they came up with the so-called top-down model, where in the top-down model, the project cost, like all the transit costs, are divided into 10 divisions, 10 categories. These are called standard cost categories. For each of these categories, they suggested ranges for the possible value of the costs, and they said as much as possible, let's stick to these values. And this was done by the following approach, where you have every cost, which basically one was, for example, let's say one was rolling stock, the other one was real estate, the other one was track. Each one of these major cost items were supposed to follow a so-called log normal distribution. In other words, it's not a single number, it's a range. And that log normal distribution has specific characteristics. How to identify those specific characteristics? You can identify that with 2 points on the curve. One was the deterministic estimate from the cost estimate that was prepared for the budget. That was considered to be a 10% cost. It means that that cost, after removing contingencies, there was a 90% chance that it would be exceeded. And then they estimated the 90 percentile. And the 90 percentile was estimated by providing the beta value, which is a multiplier. And that beta value varied between 1 and 2.5. So you will take the estimator's estimate, remove the contingencies, multiply by the appropriate beta that the guide book, the FTA oversight procedure guidebook provided, to come up with the 90%. You have these 2 points, and mathematically you have the distribution for this. And now your project will consist of a number of these graphs that when you add them up, you will end up with a total distribution for the total project cost. The ranges for the beta are provided in this table, and these are available in FTA guidebooks. So the final outcome would be an S-curve. It's a cumulative curve for the project cost. In one of them, you assume independence between the cost items. In another one, you assume that every cost item is correlated with the other ones. And then the FTA came up with an approximation between the two that's shown in this yellow graph. I hope that it shows that on your monitor. And based on that, you would be able to identify again your project budget, depending on, let's say, for example, if you want to be 80% sure that you have enough money, then you look at the cumulative probability of 0.8, you read horizontally, and then you come down, and that will give you the total required budget. So that was a top-down approach. And right now, I think that the procedure calls for whatever the owner thinks is the right approach. It has to be defensible, whatever you want to do, but still you do require to do a probabilistic risk assessment for the project. So I think that would take us to the second part of the presentation. In the first part, we saw the importance of dealing with the uncertainty and the fact that these costs are subject to all kinds of variations. And the risk assessment was a method to sort of try to understand these variations and come up with a reasonable budget to cope with this. The second part of the presentation is a study that we finished last year and was published in the Journal of Construction of ASCE. And as I mentioned, Federal Transit, since 2003, has been requiring a formal risk assessment on new start capital transit projects. Now, it is done at considerable cost and effort. And a lot of time is done by the owner of the project and is being supervised and also being observed by the PMO. And based on that, the risk report is being published, and then the mitigation criteria is developed. So we wanted to sort of see, okay, can we say that implementing this formal risk assessment has resulted in an improvement in project performance, and the project performance being how well we are doing with respect to budget and how well we are doing with respect to meeting the schedule. So in order to do that, we have to take a look at the transit project life cycle. It consists of several phases. The first phase, which is the planning and development, involves the generation of draft environmental impact statement, followed by the final environmental impact statement, followed by the detailed engineering, and then at the end of the detailed engineering and the design with build projects, design build will be a little bit different, that hopefully will result in a full funding grant agreement. And the full funding grant agreement is a statement, is a document that tells what is the commitment of the federal government and the level of the funding that the federal government will make available to the project. And then the construction phase will start. So when we are talking about the cost overrun, we have to be mindful how we are calculating this cost overrun. Is this with respect to the conceptual phase? Is this with respect to the end of preliminary engineering phase? Or is this with respect to the end of final design? It makes sense to assume that if it is based on the end of final design, that the amount of cost overrun will generally be smaller because the cost estimate prepared at that point is based on complete design, so we have a lot more information. So the cost overrun in the article has been calculated by the ratio of actual cost minus estimated cost divided by the estimated cost. And this estimated cost could have been prepared at the end of alternatives analysis, or at the end of FEIS, or at the end of uh, complete design. Data collection for this analysis took a long time. We collected 81 detailed cost estimates for the projects. We needed both the actual cost and also the cost in different phases like AA and the PE and final design. And we looked at different sources. Some of the major sources are listed here. The oldest source comes from the study that Pickrell did in 1989, and then we have the recent before-after studies that are published by the FTA and become available as they're completed online. So thanking all of those people who worked before us in collecting all this data, we came up with 81 projects, and we sort of could tell that for these 81 projects, the average cost overrun with respect to the cost estimated in the phase of alternative analysis, that's really at the same time that DEIS, draft environmental impact statement, is prepared, is about 31%. And depending on which source of data, values will be different, but that's to be expected because these are only component of all these 81 projects. So that's a sort of a grand average, 31%. And the reason that we look at the alternatives analysis is that because that's when it's a decision-making point. Do you want to continue with the project or not? If the results of the alternative analysis is promising, based on that cost estimate that is presented, then the project owner, which a lot of time is a transit agency, would be able to get the approval from the Federal Transit Administration to get into preliminary engineering and also getting into conducting the full environmental impact study and finish the final environmental impact study. So it's important. It's a decision-making point and has like financial consequences, not for only the state, but also for the federal government. So when we look at the results of this study, and the paper is available in a lot of detail, but sort of the result of the study showed that the cost estimate that has been prepared at the alternative analysis draft environmental impact statement, the capital cost that you can find in those reports have improved over time, meaning that the actual cost minus those costs that were estimated has shrunk somewhat. The curve here shows that the blue line is sort of in representative value for the amount of cost overruns, or the average value for the amount of cost overrun. And you can see that the general trend is that since 1970, this trend is downward, meaning that there is improvement in the original estimate that was the decision point to move into the next phase of the study and committing major government funds to a transit project. I'm not going to belabor too much about the statistical significance of these numbers and so forth, but this is based on 68 projects. The reason it's not 81 is that it was not possible to find cost data at AA finished cost for all the 81 projects. That's what it was available. Two other results of the comparison was that in the major projects have significantly higher percentage cost overrun. I mean, yesterday during the presentation, but we did see that larger projects tend to be affected by cost overruns more compared to smaller, simpler projects. Here, indeed, the actual analysis, the statistical analysis of the data showed the same thing. It put an arbitrary red line here for $500 million mark. All the projects were converted to $1984. And you can see that projects less than $500 million, the amount of cost overrun is somewhere around 25%, between 0 and 50%, while for the projects larger than 500 million and also towards the larger ends, the amount of cost overrun exceeds 50% sometimes. So that's one of the findings that the data corroborated. Another point is that percent cost overrun increases as project implementation durations increase. I think that was another item that also was mentioned yesterday during the presentation. As the project development length increases, duration increases, there will be more chances for the scope creep and increase in the cost of the project and what we call cost overrun, meaning that the amount of expenditure beyond your original suggested budget. And again, here the benchmark was the cost estimate provided at the alternative analysis phase. And you can see that the project implementation, as it gets longer than like 10 years and so, the amount of percent cost overrun increases as well compared to shorter duration projects. And finally, the efficacy of the FTA's risk assessment program. Remember, one of the reasons that we did the study was to sort of see, okay, was FTA successful in requiring the probabilistic risk assessment for new start projects? So for that, we look at the amount of cost overrun as a percentage of full funding grant agreement. If the project was finished within full funding grant agreement, then it would be assumed that the project was successful. Now, with that sort of definition and framework, it shows that overall, the percent cost overrun for projects after 2003 improved from 6.7% to 3.1% compared to project prior to 2003. So, in fact, the percent cost overrun has become half of what was prior to 2003. And that goes, and by the way, the distinction between these projects was the date at which the federal funding grant agreement was signed. So prior 2003 and after 2003. And now the issue is that we had only 54 projects where we had the required data to do this analysis. 20 of those happened after 2003. The FFGAs was signed after 2003. 34 of them was prior to 2003. And there is a marked improvement. However, the number of data does not make the study statistically significant. So it's sort of we put a disclaimer here. By the way, nobody funded the project, but still, for the sake of accuracy, um, the, the result of this hypothesis test, the t-test, is not statistically significant, but I think it provides information. I mean, you have gone from 6.7% to 31.1%. So that's a marked improvement. You might say, okay, but it's based on a small sample size. The sample size is about 54. So I mean, we can make our own judgments. So in general, there are a couple of points for optimism. Uh, First of all, obviously the average cost overrun has improved. Also, we note that since 2003, the development length of the project became longer than a project prior to 2003, and that's partly because the project has gotten larger. So you can see that the projects after 2003, on average comes about 450 million. Project before 2003 come at an average 350 million. So because the projects became larger, we were expecting the cost overrun to go up. The implementation duration went from 9 years to 10 years. So again, we expected the project cost overrun go up. Despite that, the percent cost overrun has improved. So I think that we can be uh, optimistic regarding the trend of the management and performance of transit projects based on the data that we have had so far. So that will uh, conclude the second part of the presentation, which will look at the performance of cost in transit projects over the past uh, 40 years, with a specific interest being year 2003, where the new requirements of risk assessment were implemented. The third part of the presentation is really a description of a research that we are right now conducting. And this is the use of uh, natural language processing techniques to help in collecting the process of data collection with respect to transit projects. Our interest in this case, the domain is transit projects. And one of the issues that we have uh, faced in collecting the transit data with respect to cost, with respect to causes of cost overrun, has been being able to have access to all the different sources of data. And then the amount of time that it requires that allows us to sort of extract the data. The general idea was if we can somehow automate this process of extracting relevant information from large documents, from large resources, then that will speed up uh, identification of the sources of relevant data so that we can basically review more information and hopefully make better decisions based on the more information. So the objective of this research is to develop an intelligence system that can automatically detect project-specific risk from a broad range of open source text data, such as news articles. And then we applied that to the news articles because of the challenges that it presented. Uh, in order to do that, you do need to start with a dictionary of the risk. In other words, the lexicon, because you expect the computer to go and start detecting some words that is familiar to the computer, and or at least to some form of the words and phrases. So one step in this was to go and identify the major risk that has befallen the different projects, and we used the work of many different people that have worked in identifying the causes of the risk, came up with a list of 26 risks, and then combined them into 5 risk categories, like risk design, project management, construction risk, natural hazards, and social and economic risks. And the purpose to categorizing the risk is generally is easier to work with 5 items, 5 categories, rather than with 26 or sometimes a lot more number of risk factors. So that's where you need your like dictionary, your lexicon of the risk to start developing. The process of text mining in general uh, is the being able to uh, collect relevant information, meaningful information, such as patterns and trends from the text. And the text mining has been adopted in construction. Our area is construction management, that's our research. So in construction, a lot of work has started in the text mining, and I've given several examples here. They mainly deal with contract language, and people have worked and have been able to extract relevant information from contract languages. It's not complete by any stretch of imagination, so the research is going on. But in general, text mining basically uses one of the 3 approaches, 3 broad areas. Text classification and text clustering tries to assign different risk types to specific uh, classes, to specific classifications. And information extraction goes a little bit beyond that. It looks at the word and the phrases and also the relationship between these words. It looks at the sentence structures and the grammar and tries to sort of make sense of the uh, way that the certain words appear in the text. So uh, the process that has been undertaken here, mainly by man here, the first step was to collect the news articles. So uh, much of the newspapers are already available in a digitized format. University libraries have access to those. What she used is Nexus Uni, which has a large number of circulations that has been digitized. So she used that to identify 400 news articles from 28 transit projects. These 28 transit projects were randomly selected from the population of 81 transit projects that have been identified before. So she selected the subset of those 28 projects and basically went and did the literature search, identified 403 news articles. The second step was to use the computer to automatically extract risk paragraphs from these news articles. So when the computer was done, 316 articles out of the 403 articles had risk sentences within them. And each risk sentence was extracted plus 2 sentences before and 2 sentences after the risk sentence, just to make sure that we do not miss the context. So eventually we had something like, I don't know, 2,000 sentences. The main building block here in this research is a sentence, right, and a word or like a paragraph. And then we went through that group of students to identify each of these risk sentences as a risk versus non-risk sentence. So right now we have sort of simplified the problem and trying to identify different types of risk to the fact that the sentence is risk or non-risk. And then she used a special requirement, the special conditions to identify a risk sentence, meaning that any one item from a single list like cost overrun, delay, or unscheduled, or 2 words co-occurrence of any items from the 2 lists. So time, milestone, budget uh, that appears in conjunction with increase or insufficient or escalation. That will make a sentence a risk sentence and will make it eligible for extraction from the document. Then the next step is to take these risk sentences and turn them into a mathematical representation. The process is called word embedding. and you use a certain mathematical operand to label the sentence that was reviewed as a risk or non-risk sentence. And that's basically the process of identifying a risk in the, oh, okay, I guess I have, okay, let's start it. I had a problem with the software. So the classification of results, remember, was to identify a sentence to see if it contains a risk sentence or if it's a non-risk sentence, which is basically that's not relevant to what we want to do. Right now, the computer, the program that Nan has created, is makes the right choice in about like 70, between 72 to 74% of the time. Still, there's a 25% chance that the sentence will not be correctly labeled at risk and non-risk. The reason for classification errors is that there's always the risk does not show itself with the lexicon. Sometimes the risk is in the context. So those are the type of things that the computer is going to miss. So obviously the process would be to make the system more smart so that it can sort of use the context of the sentence to decide if this is a risk sentence or a non-risk sentence. I think basically at the end of my allotted time, let me see. Actually, that's I'm almost done. So I'll just give you the overview of the future research. So in general, remember the general idea is that we want to expand this risk versus no risk to be able to identify different types of risks. We want to be able to go through different documents and sort of see, okay, was that a different site condition cause of a risk, or was it the cost of real estate cause of a risk? And for that, you need to expand the complexity and the range of the approaches considerably. You go to multi-labeling and using a number of methodologies that are available. And another potential use would be to sort of look at the history of the evolution of different risk factors. This is from a paper that one of my colleagues in Georgia Tech published. And you see that these are different risks, and they show the importance or the weight of each of these risk factors over the past 20 years. These risks sometimes become more important, or with the advent of technology or obsoleteness of some of the approaches, some risk may not be relevant anymore. So that would be good to sort of apply that to the transit risk. And finally, after the system is working considerably okay, the process will be validating the findings, and that can be done either by interviewing and also by checking against the before-after FTA reports to sort of see if the conclusions of the FTA report is more or less compatible with what the automated risk extraction methodology is able to provide. I think I will stop. I'll be more than happy to answer any questions that you might have.
Excellent. And thank you, Ali, for going through those slides. Really interesting information about risk and cost performance, risk mining. I have a bunch here. For those of you on the live webinar, please insert your questions into the panel here at the side of your screen. And questions for both Ali and Nan. They're going to be around for the next 10 minutes or so to answer them. But one of the things that I wanted to start with, and kind of particularly compelling for us, right, is the broader goal of our initiative is to help transit agencies and projects bring down their costs and those kind of things. So you seem to speak pretty highly of the FTA's required risk assessment. It seems to be a good step. It seems to also have some positive outcomes. What do you think are the next phases for that? How could it be improved, both in its actual function, like the requirements into it, and then And then are we doing enough of it at agencies?
Uh, Paul, uh, I was just giving the outcome of the studies, but the studies showed that overall the performance has improved a little bit. And as I'm sure you realize, it was a statistical analysis. So it didn't show any causes. It didn't show that our estimates are better, our performance is better because of that program, because of the FTA's risk assessment program. It just simply says that with the projects that has FFGA's signed after 2003, it seems there is marked improvement. It could be due to the risk assessment program. It could be due to the more awareness of the public. I mean, these days we are more sensitive about these project cost overrun. Probably that's what triggered Inno study to look into what other countries are doing. Basically, we all realize that maybe we are doing something that is causing too much uh, expenditures. So awareness, I think, has also been responsible for this improvement in this cost estimates. With respect to the actual process exercise of risk assessment, if you ask me, one of the big issues is that, and I hope my intention is not to say anything bad about anything, because people have good intentions, but the, doing a risk assessment for the owner of a project, let's say an agency, owner of the project would like to see that project built. If the owner is not optimistic, he or she would not go after that project. They think it's going to be successful. So it's almost an uphill battle that you go to a meeting and try to identify the things that can disrupt the project. And that's why a lot of times the risk assessment, the estimates that come out of it is still below what will happen later on in the field. Is an inert optimism on the side of project owners that tend to see the good portions, good sides of the project, and think that all the opportunities are going to happen, and probably the worst of the risk may not happen. And that's why we don't see more more success.
Yeah, I was looking at some of your really interesting charts, and not only do you show the trend line and the expected range, but there's a lot of outliers in the data,
Exactly.
right? Some mostly on the cost overruns, but there are a few cost underruns that you have in your data where the final cost actually came in lower than expected. Do you have any insights into those particular projects and what happened and why a project ends up being cheaper than it expected to be?
It's quite possible that the owner, especially the after the first phase of risk assessment and the FDA wanting to see these projects coming under, that they end up putting too much contingency there. I'm just speculating because I have to look at every project different. But sometimes you have, like, for example, I was in a presentation. It was a representative from one of the states, and he said that when we got the budget, we realized that we had 38% contingency, and we said we should be able to do it better than this. He said, no, no, these are guidelines. We just follow that. That's what the formula gave us. And I said, okay, sure, why not? What happens in these places where you have more money, you try to find things to do. I mean, you just add to the scope. So you're right. It happens, I know, but it's not very common that you end up with actual negative cost overrun.
Got it. So one of the things that struck me about a lot of this work is there's, there's a particular focus on public transit projects, in part because there's data on them, and so it's
Yes.
a convenient thing to analyze. Have you or your team looked at highway projects to do similar analysis to see if the same kind of conditions are prevalent in highways?
Um, People have worked on that. Several papers have been published. If you want, I can dig that and send it your way. But similar work has been done. In general, you will see smaller cost overruns because like 95% of highway projects are very small. I mean, if you count the projects, most of them are like paving, and you do not have much risk in that. They're only the ones that involve tunnels and bridges and like big interchanges. Those are the major projects. But all of these 81 projects, transit projects, are sizable compared to a typical highway project. So you want to compare transit projects with highway projects that are larger than a certain size. And not just the dollar value, because if you're basically paving 100 miles of highway, still is not the same as building a transit line in an old city where nobody knows what's underground. So maybe the comparison would be a little bit misleading.
That's fair. So I'm also really interested in the last part of your research, the data mining. The really very kind of a cool data set and some very compelling outcomes. How do you hope to see that applied in real life, and who's going to take that up and use that?
I think I can let Nam answer that, but I mean, the reason, the main impetus, given the fact that I guess we're running out of time, the general idea, Paul, is that we've looked at that as a basic research. And we think that in the future, I mean, if we can make the system work, meaning that instead of having to go through all these different sources of data, like for example, newspapers and magazines, they are published all over the country every day. And maybe there are some useful information in some of them. So going through them manually is counterproductive. But if we could think of a system that can do that for us automatically, then it can find its benefits in many different directions. So it's almost like to be honest with you, it's like a basic research rather than I tell you, okay, if you do this within 5 years, you will be able to do a better risk assessment. I don't think I can say that. It's just trying to figure out, is there a way to solve that problem? It's one of the very like a hot areas of research, if you will. But because it's so much relevant to the area of transit, we thought it would be a good addition to the discussion that we had.
Got it. So
Yeah,
please, Nan, go ahead.
So I guess I can add a couple more points to the question. So the ultimate goal of the research would be that we have a automatic risk identification system that can achieve acceptable accuracy. So with this system, firstly, we can use it to automatically generate a risk checklist for each new start project. So currently, to generate a risk register, you either do like interviewing experts or like going through a lot of documents, but that is like a lot of manual work and it's cost and time consuming. So if we can have a system that can automatically generate a list and then human goes into reviewing the list, that would save a lot of time. And also another thing is it kind of help index and document the knowledge we learned from the previous projects. So we all kind of know that in construction industry, a lot of companies or agencies are not very good at documenting the knowledge or lessons learned from previous projects. So our goal is to utilize all kinds of textual documents, including like open source data, such as news articles, or like before and after studies published by FTA. So with this, through utilizing all those textual documents, we can kind of harvesting the risk knowledge stored in those in those documents, instead of the current situation where all those kind of knowledge is stored in individual mind. So it's hard to, go through from one generation kind of to next generation. So this is also another goal.
That's great. Well, and Ali, at the very beginning, I think you mentioned some of the benefits of why we do this, right? For better communication, educating public, making sure we have realistic estimates, right? I mean, there's a lot of reasons why we should be doing this, and it's also as an observer, right? I don't do risk estimation. It's always frustrating to see things left out, like inflation or scope elements or other those kinds. You kind of scratch your head and say, why is this happening? I think you touched on the optimism bias, right, that a lot of sponsors have. They want a project that is lower cost. So what I mean, I know we're pretty much out of time and need to wrap it up, but just wanted to see if you had any closing thoughts about the next phase of your work and how it fits into the larger puzzle of how we get better estimations of projects at the very beginning.
One of the objectives that we have is basically, and as you know, there are methods that have been suggested in UK to cope with the optimism bias, which we think for several reasons it may not be completely reasonable because of the obviously projects are not the same, so you can come up with huge budgets for the projects. It's not a good idea to come with a very big budget because then you will not be able to use your money efficiently. I think that one area of research is given a number of people, can we come up with a methodology that can reduce the estimator's bias? And that estimator can have different backgrounds. One could represent the real estate acquisition, one could represent the geotechnical. Each one of them, is there a way that from the responses that you hear from them in a risk, for example, workshop, that you can sort of help him or her, guide them to sort of reduce that bias? The reduction of that bias will go a long way to improve the estimation for the cost of the project.
That's great. And with that, we'll conclude. Certainly want to thank you, Ali and Nan, for both presenting and sharing your current research. Again, this is going to be posted on the Socio website for the symposium, so folks that weren't able to listen can go back and listen to this and when the recording's posted. Just a few other things for folks. The next session starts at 1:30 p.m. Eastern, so in 27 minutes. You can navigate there through the agenda tab on the platform, and also please join us at 2:30 for our debrief panels, where we're going to be having just a casual Zoom session talking about the day. So everything is looking good. We've got through a bunch of questions, and again, really want to thank Ali and Nan for their time and dedication to not only this broader program, but to the overall effort of bringing down the costs and timelines associated with big projects here in the U.S. So thanks again for sharing your insight, and we will look forward to collaborating with you soon.
Definitely. Thank you. Bye-bye.
Okay.
Thank you.